Hi guys, Azhar here. Welcome back to the tutorial. Now this is actually part 2. All right, so if you want part 1 on how to actually get the form of this project, make sure you click the link that's up here somewhere. Okay, so that video takes you to part 1. Make sure you do that first before coming here. In this video, we're really going to look into the facade system. So we're going to go over some intersecting planes. We're going to cover some paneling tools. It's going to be awesome. So again, make sure you subscribe if you haven't already. And again, for this particular example too, you may want to download the latest file from the link in the description box below. Let's get right to it. All right, guys, part 2. Let's do this. Over here, I have a series of photos. Let's have a look at these. So for example, here, let's see if we can zoom in on this one. You can see that the facade clearly has these like dividing columns here, right? You can see this is almost vertical, but then they start to slant off, and you can see all the way down here at the end, they're kind of going at an angle. Let's find a different photo to see this. Here we go. This is a better photo here, where you can see, again, this series of balconies is kind of adjacent to this wall right here, right? All the way to the edge. But then as you travel down the building, you start to see they start to curve and start to go in an oblong kind of diagonal direction, right? So how do they do this? What is the rationale behind it? And in order to do some of that, I'm going to show you how to sketch some of this in Grasshopper. Of course, it's not going to be exactly this. We would have to spend a couple of days to really get to the exact way that BREP Angles Group managed to do this facade. But for the sake of a YouTube tutorial, I'm just going to show you a basic overview. If I was working at Big on this project and we just wanted an initial sketch of what this starts to look like, I'll show you the process of how I would go about and do that. Okay, so let's go ahead back to Rhino. So again, I just want to reiterate that if you did not do part 1, please go back and do part 1. Okay, and then come back here. This will make a lot more sense. So in part 2, you see I've kind of set it up a little bit differently for you. Most of the definition is here, and I've given you some extra stuff down here as well. We'll talk about in just 1 second. So first, let me show you like how to actually create those divisions. Okay, there's a couple of ways. All right, but notice that they usually go in 2 directions, right? So you're looking at a grid. Even a rectangular grid usually has columns and rows. They usually have things going up and down and things going left and right. So the first thing is to identify what's going up and down, what's going left and right. So the up and down are these lines right here going across the building, right? That start to go on the diagonal, and then the left and right are kind of these balcony lines. Okay, so we're going to create both of those separately and then join them to create a grid and then populate that grid. That's how we're going to approach this project. All right, so how do we do that? Here in Rhino, let's go ahead and try one of them. Now the thing is, like, what surface are you going to do this operation on? Are you going to do it on the cut one, right? This is the cut one. Remember, we cut this out in part 1, which is right here. Okay. Do we do it on that, or we do it before it's cut? Okay, which is, let me isolate it, this surface right here, the sweep. I would recommend doing it on the sweep, because if it works on the sweep, you can always edit it for the next one, which is the trimmed one. Okay, don't work on this. As a general rule of thumb, especially when you're working with panels, you don't want to work with panels that have holes in them, or surfaces that have holes in them to do paneling. You kind of want to work on the overall one and then adjust it and remove those cells that are missing in any of the cutouts. That's just my rule of thumb. So I'm actually going to use it on this, right? BREP front facade sweep, in which case I'm going to hide this. So I'm not looking at this, okay? And I can copy this one over. So BREP front facade sweep, I'll just copy it down here somewhere and just start working on it over here. So the first thing I'm going to do is a contour, okay, to create some striation lines that go left to right. So if you haven't used contour before, it's pretty straightforward to use, and you'd probably want to read the descriptions. But the second one says a set of BREP or mesh contours. This is what we want since this is a BREP. Go ahead, click that, and let's start entering some information. So what's the shape you want to contour? Well, we know what the shape is. In fact, this is getting a little confusing with the courtyard in there, so I'm also going to hide the courtyard. There we go. So let's go ahead and plug this in here. All right, now it's asking for a point. The point is pretty important because you want the contours to start from a point where you can measure from, right? So if I measure from the bottom, and right now the default is the origin, which is actually right here in this corner, then it wouldn't make much sense because I'd be slicing this at some weird number as the contour heights add up. So you probably want to pick one of these numbers, and since I know this number here, this number 2 in the back, point number 2, which happened to be up here, if you look for your list item where we pulled out the second item and got the high corner point on podium, all right, if I click it, you see it highlights this bottom corner point right here. That's the point we want. So again, just grab this, copy, paste to create a double, and bring the double down like this, and use that under point. Okay, still not done. As for the direction is straight up, 0, 0, 1. That's up in the Z. That's fine for us. And the last one asks for distance. Like, what is the spacing between each contour? So let's say these are double-heighted spaces, and we want the distance to be, let's say, 12 feet. Okay, for double-heighted spaces. Go ahead and put that in. In fact, I can also write as floor height in feet. Okay, this way I know exactly what that slider is, and you can see already that's where those lines start to come from. That's the left-right lines. Yeah, that's where it originates. Now, of course, you can change this. You can just bring this down to 6 or even lower, and you start to see just how many curves you get, and you understand the curvature of the surface by contouring it this way. I'm going to leave it at 12 just so we kind of see it a little bit clearer. All right, so that takes care of the left to right lines. What about those up and down lines? So this is where the geometry rationalization part comes in, and I really dive deep into this part when I train professionals through Computational Design Studio. So if you don't know about that, go to compdesignstudio.com to find out more. But what I would do as a basic sketch, right? Someone says, Azhar, let's see some balconies. Let's just see something on here, right? We don't know exactly what it is, but as a sketch, right? What can I do in Grasshopper? This is probably what I'd do. I'd use some kind of rationalization strategy. And what I'm going to do is draw a series of lines that start perfectly horizontal here. Let me go in the top view, for example. We'll talk about this in 1 second, but here, I'll probably start with something that looks like a line this way, okay? And then, starts to draw lines like this across the surface, like that, and those would be my verticals. Okay, how do I do that? How would I draw that? Well, exactly like I'm doing right now. First, I need to draw this line. Then I'd probably draw another line here, and then I draw lines in between them. Okay, so let's go ahead and do that. So what we can do is, since we have this point right here, the high corner point on podium, which is right here, it's under this X right here, okay, we can move it to the left and then make a line and then make another line like this. Okay, let's try that. So let's take that point right here, point number 2, which is right here, and move this point, okay, in the X direction, because it has to go left, right, over here, so that's the X, except I'm not going in the positive X. I'm not going towards the right. I'm going towards the left. So it's actually going to be reversed. So I got to reverse this direction of the X. Okay. And how far are we going? Honestly, I don't know. I'm just going to type in, say, 500. Okay, 500 feet. And let's see where it ends up. Oh, that's kind of close, right? So, I mean, this is a slider, so we can always adjust it as needed. So let me delete these lines. And here's that point. So we could give this a name. So we can give this a name such as, call it cone center or something like that. Okay, since what we're going to make starts to look a little bit like a cone. So we'll call this cone center here. And then I need to draw that line, right, from here to this point, and then from here to point 3. Okay, that's not so hard to do. So draw a line. From where? From the cone center to where? To point 2, which is this point right here, high corner point on podium. Okay, that gives us this line. And then I'm going to draw another line from the same point, the cone center, except to point 3. Where's point 3? Well, if you come up here in the definition and you look over here, no, actually over here, this area here, you should see I have point 3. I actually labeled it for us this time. So you can just copy and paste that, grab point 3 now, come down here, and use that instead. So now you see you have the cone center, which you can move a little bit, okay? And you have it coming to here and to here. Now I'm going to extend these lines just to look at it like a graph, almost like a diagram where I can extend these lines and really see them cross through the building. Okay, that's just a nice visual way to look at them. So I'm going to extend these curves. Okay, and the way you can use extend curve is you can extend it in two ways, either at the beginning of the curve or at the end of the curve. Now I only want to extend it at the end of the curve, so I'm going to feed a 0 for the start length. So double click, use the double quotations to open up a panel, enter a 0, and you can use that as the start. Now the end, again, I don't know how much to extend it. I'm just going to write a number like 500 again. And yeah, that seems to look decent. Okay. And if I like the number, I'll turn it into a panel. So let's see in 1 second. Copy and paste this right here. Put this under the curve. And yeah, that seems to look okay. Yeah, 500 seems to be all right. So I'm going to replace this with a panel, this 500. Anytime I like a number and I want to stick with that number, I always use a panel. And the reason I do that is anytime I see a slider, I feel like flexing the slider a little bit and just seeing what happens to the model, right? Where this is not going to affect it. This is just a visual thing. So why have a slider for it? And I can use a panel. So what you can do is, this is a good trick, is if you want to ever move wires from one output to another output, use Control Shift, and you can unplug them from one and kind of plug them into the other one. Just like that. All right, so now you see you have these extended lines. It's just a nice visual way to kind of look at your model. Now, I need to say that anything you do in Grasshopper, there's like a dozen ways to do the same thing. So anything I'm doing right now, I'm sure some of you are thinking like, hey, I know 10 other ways to do that. Yes, because there are 10 other ways to do this. Okay, I'm just showing you one way, probably the way I would do. And also, since this is like a tutorial, a YouTube thing, I just kind of want to also show you other components and commands you can use. So you may say, why is Azure doing it the long way? And it might also be just to show you some other components. So I'm going to use Tween Curve. This is a super useful component. Tween Curve, what it does is you can add one curve and a second curve, and it will kind of generate and interpolate a curve in between. Okay? In between that curve. So here's a line that it generated. Now, how did it know where to draw the line? If I hover over factor, you see it says 0.5. So it's kind of halfway in between the two lines. So if I gave it a 0.25, for example, it'd be closer to one line, and then 0.75 would be close to the other line. And so I can draw actually a lot of these if I have a list of numbers between 0 and 1. The easiest way to get a list of numbers between 0 and 1 is using range. Okay, because range automatically gives you a list of numbers between 0 and 1 like this. You see, 0, 0.1, 0.2, all the way to 1. If I plug that into factor, you see that I get like 10 divisions or so of the lines. However, what if I wanted more? Well, there's this thing called steps. So you could enter another number, let's say 25, and that would increase that number here. So you can control with this slider how many divisions you want. So I'll leave it somewhere where I was earlier, like 25 or so. Okay, you can even relabel this. You can call it vertical divisions or something like that. You know, some people would do it this way. If I was working on the real project, I would do it by feet, just so I know minimum feet, maximum feet, because, you know, a lot of it is dimensional based. But anyway, here is these curves. But so what? So I have these curves, but they're all in plan, right? They're not actually on the surface. So how do I get these on the surface? Now, some of you may be thinking, well, we can project it. There's a couple of ways you can do this. Whenever you have a surface and a curve trying to cut through it, I don't like using project. I like, especially if it's a straight line, I always use a plane to intersect that surface. So the way you want to do that is use BREP plane. So if you type BREP plane, you get this BREP plane intersection, okay, where a plane will intersect a surface or a polysurface. Okay, so what's the surface or polysurface we want to intersect? It is the swept facade, this one. So I can just get that output here and drag it over here. Okay, it's turning red because I have 0 planes. There's no real plane going in there. The world XY is going through it, but it's missing it since it's going to slide right under this thing. So I actually need a plane on each of these lines. cutting through the surface. That's actually not so hard to do. I can type in construct plane, okay? Construct plane to create a new plane, and you can see here, all it needs is where's the plane's origin, and give me an x-axis and a y-axis, okay? And I know this may look complicated, like how do I actually do this? But it's actually not so hard. Look, the origin, you can place all the planes right here, okay? And then have them slice through the surface like this. So placing all the planes there means all the planes have the same origin, which makes it easy because we know where that would be. That's the cone center. So the cone center is the origin of the planes. Okay, next is the x-axis. Okay, what on earth do I give as the x-axis? Do I need to create a new vector or something? No, not necessarily. Since these are all straight lines can be read as vectors, which is great. So all the tween lines can actually become my x-axis. Okay, now what about the y-axis, right? I have one axis. What about y? I don't have other lines here. But since this plane is a vertical plane, it needs to kind of sit straight up, you know, vertically and cut through this. The y-axis is actually just a single z. And so now you have all these planes that are vertical planes going to slice through this surface. Now you can't see the planes. Some of you may see the planes. It really depends under display. If you go to preview plane size, what number you have. Right now I have 3, so that's 3 feet, which is super tiny. If I make that 300 feet, you actually start to see the planes. I'm going to make it much larger. Let's say 3,000 feet. And now you see the planes, okay? So these are the planes. You can see they're centered on that cone origin there. It's a little bit hard to see. Okay, if I go in my top view, again, they're kind of centered here, and they're literally these lines right here. So the plane is, you can see, slicing through the entire building, right? And planes are infinite, so you don't have to show it this big for it to actually work this big. I'm just showing it to you like this so you see how they're intersecting the surface, and now I can tell that it's actually much harder to see. So what I will do is actually bring that preview plane size down to say 100 and keep it over here on this side, and go ahead and finish this component right here. So BREP plane, again, we've entered the BREP. Now let's enter the plane, and what is the result? Let's look at that. Look at this. You see, along one edge it stays vertical, but then as it moves through the building, you start to see it angle away, right? And if I look at this in the top view, you start to see this is kind of the language you get. And if I go back to this image, you see that's kind of similar, right? I mean, this is like a, you know, an overhead aerial image, so it's not going to be exactly accurate as, say, for example, a perfect plan drawing, which I can't really find here, but nonetheless, you kind of get the idea, right? And you can change like how exaggerated that is just by adjusting where the cone center is. What do I mean by that? Like, for example, if the cone center is very close, you know, that gets more and more pulled and exaggerated, you see? And if the cone center is really far, they start to look more and more parallel to each other. So it kind of depends aesthetically. Again, this would be a sketch. I would probably take this and mess with this and start to look in 3D at what the resulting you know, panels look like and if we like them or not. So let me start hiding some of these now. Hide this line, hide this line, hide the extension, hide the tween, hide the planes, and I have these curves. So I'm also going to hide the surface because let's just look at the curves. So if you got this far, I just want to remind you that if you're new to Rhino and Grasshopper and you want the most effective way to start learning, take my free intro course at onehourgrasshopper.com. Here I teach you step by step the right way to learn Grasshopper and how you can avoid common mistakes that most users make. I give you my personal Grasshopper template to keep you organized, my custom components that help me and thousands of others be more productive. I'll also give you a list of my favorite Grasshopper plugins. So if you want to start learning Grasshopper the right way, head over to onehourgrasshopper.com now and begin your computational design journey today. All right, let's get back to the tutorial. And here I have the curves that are going vertically and the curves that are going horizontally. I can create an actual grid from those. And the way you do that is under paneling tools, okay? You can come over here under grid and you'll see that there's one where you can create a grid from intersecting curves. Intersect curves. Go ahead, click that and drop it on your canvas. You see that it needs curves in the U direction and curves in the V direction. Okay, which one's the U, which one's the V, really doesn't matter right now. You can always flip them around as needed. Okay, so let's just start with, say for example, the contour lines that we had earlier, right? The horizontal ones, those are my U. And now these new lines that I have, which are going up and down, my vertical lines, they can be my V lines. Okay, so if it doesn't create a grid, and that's because all of these curves are coming in as individual branches, you really want everything to come in as one big branch. So you just want to right click and flatten these inputs here. Okay, this way it just turns everything into one large single list. Okay, and so then it's easier for Grasshopper to intersect those grids and give you, or intersect those lines to give you this grid. Awesome. Okay, so now we have a grid, and if you're not familiar with paneling tools, you can do a lot of different things with paneling tools. Maybe I should do a long tutorial one day just kind of going over all the different functionalities that paneling tools has. But the one we're going to use today is Morph 3D. Okay, now there's a couple of Morph 3Ds over here. All this does is take some 3D geometry that you have and place it on your grid. In this case, I'm going to take some, like, some default kind of balcony geometries that I've made and bring them onto this grid. And the way I'm going to do that is, let me see, which one should I use? Should I use list? Yeah, list looks okay. Okay, so we'll use this one. Okay, Morph 3D list. And the second you drop it, a lot of you are probably thinking, oh my God, how do I work with this? This thing has so many inputs. I'm going to get lost. It's okay. We will figure it out. Okay, don't worry. So let's see how this component works. You need grids, weights, all these different things. Stay with me. Okay, and I will get you through this and we will have an awesome result at the end. All right. So first it needs a grid. So let's give it a grid. Okay. Now it needs a second grid. Why on earth does it need a second grid? Well, when you're working with three-dimensional geometries, it doesn't know that when it puts a 3D geometry here, how thick that geometry is going to be. So it's actually going to sandwich anything you give it between two grids. So we have one grid. To get the other grid is actually really easy. All we need to do is use offset. So if I use offset, there's many different offset options. The one we need is an offset grid. Okay, so make sure you type out all the way offset grid and you'll get this component over here, okay, where you can enter a grid, you can enter a base surface, which we know we have this base surface here. Let me actually bring it over. It's going to be easier for us to look at, which is the front facade sweep, right? The full surface on the front facade. Copy, paste, oh, the wrong one. Copy that one, bring it over, just so we can see it a little bit easier. Bring it all the way over here. And that's going to be our base. Okay, then it's going to ask you, let me hide some of this. There we go, hide this. It's going to ask you the distance. How far do you want to offset it? So just to exaggerate, let me enter a large number like 125, and you'll see what it's kind of doing. You see, it creates like a second grid outside like that. You see, it's like offsets that grid out. Okay, so I'm not going to offset it too far. Maybe I'll just offset it by a distance of 1. And if I delete that and just hover over here, you'll see the default is already 1, which is like 1 foot. So it's going to be really thin. The sandwich is pretty thin, and that's okay. I'm perfectly okay with that. Okay. So don't worry about grid of distances or any of that. Oh, the main thing is we have a second grid now. So I can just plug this into grid 2. Okay. Let's continue to pattern objects. Okay. This is important because I just want to kind of show you what these actually mean. So pattern objects is what do you want to place in the grid. Now, if you look at the photographs, we come back over here and we look at, say, for example, this view. You see these balconies here? That's kind of what I want the pattern to start looking like. And you'll notice that some of these balconies are pretty wide. Some of them are really thin. Okay, let's go to another photo, for example. Yeah, here, let's look at the top view. You can see much clearer over here. Some balconies are really wide, some are really thin, and they're just different variations. But notice that each balcony also is always alternating, right? You don't really find a balcony hole, like a hole in the facade for a balcony, and a hole right next to it. There's always like this full solid gap in between, right? So that's kind of what I've done here. So if you go back to Grasshopper, you'll see that there's this big orange box over here. Okay, which actually it shouldn't say that. It should say, on yours it'll say something else. So it should say paneling objects. Okay, There we go. So these are the objects we're going to panel. And you'll notice if I zoom out over here in my Rhino model and come over here, let me go in my top view. You see these are actually all the objects. Now they're all kind of overlapping each other and it's kind of hard to see. So what I'm going to do in Rhino is select this and hide it. Control H to hide. And in Grasshopper, turn on the isolate. Okay? So that nothing's visible unless I click it. So you'll see if I click bounding box, it's really just a big box, okay, in here. And here's my first pattern, which is 2 solid panels. Here's my second pattern, 1 solid panel and 1 open. Third pattern, fourth pattern, fifth pattern, sixth pattern. You start to see the balconies kind of get smaller and smaller. And these are all 3-dimensional shapes. So if I, cycle back through them, you'll see that they're actually all shapes that look like this. And there's one big box, which is called the bounding box, which kind of encapsulates all of them. Okay, you're going to need all of this when we get to the paneling part. So let's bring this big orange box over to this paneling area. And this point, I really want to stress that paneling tools sometimes takes a lot of time. Depending on your computer, it may take a while. So I would recommend actually disabling this component, okay, but using Control E, and then plugging in, for example, the bounding box. Okay, bounding objects is the bounding box. And for pattern objects, you want to take this entwine result here and place it over there. All right, and let's just see if this runs. So Control E and see if it runs, and it won't, right? Because it really needs what's called the weights. Okay, now what are weights? What it really wants to know is like, hey, where do you want each pattern to go? And you give it certain numbers, and it lets you, and it basically tells Grasshopper, pattern 1 belongs here, here, and here. Pattern 2 belongs here, here, and here, and so on. Now, we don't know where any of these belong. We just want it completely randomized. So the way you want to feed it weights is give it a number between 0 and 1 for each and every single grid point, but we want it to be completely randomized. Okay, so that's actually fairly easy to do. What you do is just type in the word random to generate some random numbers. And you can see over here, you already have some random number generated, 0.77. And the reason you only have one number is because under number, it says 1. So it'll only create one number. We don't want one number. We want a number for every single grid point. How many grid points do we have? We have 975 grid points. So how do you extract that 975 out to feed it into the word number? You do that by using list length. Okay, a couple other ways to do it, but this is how I'm going to show you to do it. List length. So if I take this and plug it into here, you should get 975 out. And you probably won't. You'll actually get multiple 25s out, 25, 25, 25, 25, 25. I don't want that. I just want the sum of all of them. So what you want to do in this case is right-click on list and click flatten. This way, one giant list comes in, and it will calculate how many items are in that one giant list, which is 975. That goes under number to give you 975 random numbers. Look at that. So we didn't, we have a generator for us to create all these random numbers. Now we can plug that right into weights. Okay. But if you plug it into weights, you'll notice that really doesn't work. You kind of look at this file here, you'll see that it's done something on the bottom, but it's not really working. Okay. So the other thing you need to do is make sure that the way that this list looks is the same way that the grid looks. Okay. And by looks, I mean look at this input. Like actually look at the screen and you'll see that you have multiple branches. Branch 0, branch 1, 2, all the way to branch 38. Each branch has 25 items. If you look at weights, there's no branching. It's just one giant list of 975 items. So the way you can make one list look like another is I like to use match tree structure. There's a couple other components to do this. Match tree structure comes from the TT Toolbox component. So if you have the TT Toolbox plugin, you'll be able to get match tree. There's a couple of other match trees out there. But either way, what we want to do is one list to look like another. So which list do you want to change? This one. What list do you want it to look like? The grid. And look at the output now. Now it's all branches and it has the same number. of items in each one. 25 items for 39 branches. Plug this into weights and it should work a little bit better. Now notice my computer's taking a little bit of time and it has done it. Okay, now it's kind of hard to see. So first thing I'm going to do is start hiding a couple of things. So hide. What else can I hide? As much as I can, I'm going to hide things. Oh, okay, there we go. Okay, so that's looking a little bit better. But if I zoom in and examine this closely, you'll notice that each grid cell is actually rotated, right? The balcony should be going horizontally. The balconies are kind of going vertically. Seems kind of weird. Now, why is that? The easiest way to fix that is the way that we created the grid. Remember, we used the intersect curves using vertical lines and horizontal lines. Well, instead of doing it this way, which takes the vertical lines here and the horizontal lines from here, just switch them around. Okay, so instead of this going in U, this will go in V, and instead of this one going in V, this will go in U. So this just kind of flips the grid around, and ta-da, there we go, right? That looks a lot better. Let me actually look at that with like a BREP preview. So LC BREP preview, you can download this using the link below. And oh my God, that's so much better, right? Look at that. So as a sketch, we can already start to see what this facade would look like. And again, we can do anything we want with this, right? In the sense that the vertical divisions, I had, what is this vertical divisions from? Oh yeah, sorry, that's not vertical divisions, right? This is the tween curve right here. Yeah, which created the vertical lines. Yeah, so in a way it is the vertical divisions. And you can change this. So 25, let's say it's much less, let's say 15. And then you can see what that looks like, right? Okay. You can change the contour height. You can really change anything you want. It's perfectly parametric. Notice that it takes a little bit of time to calculate each run. So if you did want to mess with these, I'd recommend you first like disable this using Control E. Then you change any of these that you want. It'll be a lot faster. So say I change this real quick. I change the cone distance real quick. I go a little bit further. I change the floor height to be a little bit higher. Then I would come back and use Control E to make this thing work. You see, otherwise it's just going to be really choppy. So just a few little tips there for you guys. Anyway, I hope you guys enjoyed this tutorial. I had a lot of fun making this into like a part 1, part 2 kind of thing, since each one is quite unique. And I hope you guys learned a lot. If you found it helpful, make sure you give a thumbs up. And of course, send me some requests. I'm happy to tackle any kind of project for you guys using Rhino, Revit, whatever program you want. So it should be fun. And I'll see you guys around in the next tutorial. Take care.